Yeah, we got our test back on Friday. You did not, probably. See, just come see me.
Okay.
I have it in my office or something. After class, we'll get it. Okay. All right, up until now, when I said solve a triangle, it pretty much needed to be a right triangle to do anything with. All through geometry, we dealt with right triangles. And basically, when we talk about math, we talk about right triangles because we have that nifty SOHCAHTOA to solve stuff. But in order to use SOHCAHTOA, we need a hypotenuse to know which is the other thing. To have a hypotenuse, it has to be a right triangle. So up until now, if I said solve a triangle, the only way you could do it is if you could either make a right triangle on it, or if I gave you a right triangle. However, right triangles are just one type of triangle. Anything that's not right or oblique makes up all of our other triangles. So in fact, we did a very small portion of all triangles. It had to have a 90-degree angle in it. What we're going to do is we're going to expand that to all oblique triangles. So today we're going to start forming the base of being able to solve any triangle as long as I give you the right information. So we'll no longer be using SOHCAHTOA. We're going to be talking about the law of sines, and we'll use the law of cosines on Thursday, because we're going to spend a bunch of time on the law of sines, because we have to get a whole bunch of information straight before we can move on. All right, so today I'm just going to focus on the most basic use of the law of sines, and that is if I give you two angles and a side included. That means in between. So that's called angle, side, angle. And if you remember from geometry, you use that to prove that two triangles were congruent, or that you had, yeah, we'll just stick with congruent. We don't have to prove anything. All right, all I'm asking you to do is given information, did I give you angle, side, angle, yes or no? Did I give you angle, angle, side, yes or no? That's the only check you're doing. Now the cool thing about angle, angle, side, and angle, side, angle is all we're going to basically say is, did I give you one of these? If it's yes, we can do what we're doing today. So rather than thinking about angle, angle, side, we are going to think about it that way. But the easier way to think about it is if I give you two angles and a side, you can do what I'm doing today for all triangles. All right? So all you're realistically looking for is, did I give you two angles and a side? Because if I give you two angles and a side, it automatically has to either be this or this. Has to be. So in short, we're just going to look at the triangles and say, do I have two angles and a side? Today they're all going to work, but tomorrow they're not. So let's just practice today so that when we get to the ones that aren't going to work as well tomorrow, that we're already practiced looking at stuff. All right, the law of sines. The law of sines says, if I take the sine of the angle over that side opposite, that's going to equal the sine of another angle divided by the side opposite that angle, which is also equal to the sine of that third angle over the side opposite that angle. So just remember, lowercase is the side, uppercase is the angle. Now this is pretty cool, and it works out really well when we're solving these triangles. Before we get into actually solving these triangles, I'm going to rewrite this a bit. What's happening out there? I'm going to rewrite this just a little bit, all right, to make our life a little easier. All I'm going to do is I'm going to flip everything. I'm going to take the reciprocal of everything. So rather than writing it like this, I'm going to write it as A divided by the sine of angle A equals B over the sine of the angle B. And that's going to equal C, the side C, over the sine of angle C. Now I'm going to put a note on this, when we're going to use which one. So I'm going to use this one when I'm looking for a side. So if I want to find a side, I'm going to put my sides on top. So that's kind of how I remember it. If I'm looking for a side, I'm going to put the sides on top, and I'll have my angle on bottom. So that's what I'm looking for. We're trying to find a side. So that means I'm probably going to use this one when I'm looking for an angle. So if I'm missing an angle. When I'm missing an angle. And today we're going to primarily use this one. In the first example, I'm going to show you why we flipped it. It makes your life a lot easier just knowing to do this. Okay, so let's look at our first example. Our first example says, I have a triangle ABC. And it said, my angle B is 34 degrees, my angle C is 64 degrees, and the length of A is 5.3. So my advice to you is just draw a generic triangle. All right, doesn't have to be perfect, doesn't have to be 64 degrees on C, doesn't have to be 34 on B. All I do is I just draw a generic triangle. And I'm going to label it, and it doesn't matter how you label it, as long as the correct numbers go in the right place. So I'm just going to call it ABC. Well, it says B is 34 degrees, so I'm going to put 34 degrees in for B. It says that C is 64 degrees. And lastly, it says A equals 5.3. Well, A is going to be opposite angle A, so that's going to be my 5.3. That would make this B. I don't know B. I also don't know side C. I also don't know angle A. But do we have to do something crazy? Do we need a crazy formula to get A? I hope not. I hope you're not using sine and cosine or anything. Can tell me how easily, or how I can easily get A? And most of the time we can actually just do this in our head. Yeah.
You can take 180 minus, I think it's 98.
So we can take, I'm just going to write it all out. Well, let me just do a different color, just so we know that I'm actually doing this work. Yeah, we could do 180 minus 34, and then minus that 64, which would be 98. And what does that come out to?
82.
82? Yep. 82 degrees. So most of the time we can kind of do this in this head. What I would do, especially if I'm on a test and I'm already freaking out, I would just do 180 minus and just be done with it so I didn't make any mistakes. All right, that means I have all of my degrees. So the only thing I'm looking for are sides. So that's going to tell me, I'm going to put all my sides on top. This is the only one I'm going to need to use, is this one. So we're looking for sides. So that means we're going to use our A over sine of A. And that equals side B over sine of angle B. And that's going to equal C over sine of cap C. We actually know a bunch of this information. We know a whole bunch of this information up here. And I'm going to tell you which one is your most important one. And I usually circle it. Your most important one is if you know an angle and the side opposite. That is your most important one because that gets rid of a whole variable. So I look at angle A. I know the angle of it. I know the side opposite of it. So that means when I plug this in for A and cap A, I actually just have a number. Like it's almost already solved for you. So I'm going to throw those numbers in really quick. I don't usually write all three of them out, but I'm going to right now. I'm going to put all the information in. Well, A equals 5.3 over sine of, well, angle A is 82, so we're going to put 82 degrees. That's going to equal side B. I don't know what side B is yet, so we're going to leave that as B. I do know what the angle is, though. So angle B is going to be 34 degrees, and that's going to equal, I don't know what side C is yet, but I know my angle is 64 degrees. All right, so all of this is true, but I don't want to leave it as three separate things to solve because I'm looking for B and C. So all we're going to do is break it apart and solve for the one I need to solve for. So we use this guy because we know all of this. We know the A's, so we're just going to take that, and I'm going to write it over here. We'll just start a new column here. We're going to go 5.3 over, ooh, I'm going to move that over just a little bit. I have 5.3 all over that sine of 82 degrees. So that was all with a's. And that equals, I want to solve for b. I want to figure out what b is. So we're just going to plug in b over sine of 34 degrees. Now I just need to solve for b. And to get b by itself, I need to get rid of this sine of 34 degrees. So I'm just going to multiply both sides by the sine of 34 degrees. So we're going to treat this as just any normal solving. So I'll multiply both sides by sine of 34 degrees. Multiply this side by sine of 34 degrees. My sines are going to cancel out. I'm going to switch the side that the b is on. So I'm going to have b equals sine of 34 degrees times that 5.3 over sine of 82 degrees. Real quick, who knows the sine of 82 degrees?
0.99.
Who knew in their head, though? So what are you going to need? What are you going to need? You're going to need your calculator. What mode does it need to be in?
Degree.
It needs to be in degree mode, otherwise you're getting the wrong answer. So go ahead, if you have your calculator, I'll give you a second to take it out. What is b going to be about? I rounded it to the nearest tenth, but I think it rounds up even further. I'm trying to remember. Did anyone get it?
About
2.9. I rounded up to 3, I think. I think it was like 2.99.
Yeah.
So b should be about 3. All right, so I know b. The only thing I need to find now is c. We're going to do pretty much the same thing. I'm just going to kind of flip the side that it's on. I'm going to say, well, c, well, that goes with its angle. Its angle was 64 degrees, so sine of 64 degrees. And that's going to equal a divided by sine of a, which we know was at 5.3, over the sine of a, which was our 82 degrees. So we just basically take the one that we know all the information for and just compare it to the other ones. We multiply both sides by sine of 64, and we come up with c equals sine of 64 degrees times 5.3 over sine of 82 degrees. And this one I completely forgot the answer to, so I'm going to look it up before someone gives me the wrong answer. You should get out about 4.8. Lily, do you have a question?
Would you put?
First thing. So you look at C. C equals 110 degrees. That's obtuse, right? So there's two types of people that draw triangles. There's lazy people like me, and then there's fastidious people. A very fastidious person, this is just an example, you don't have to do this, I'll show you the two different ways. One way you could draw this triangle and say, hey, I know C is obtuse, so I'm going to draw it obtuse. Alright, I can look ahead and I know it's obtuse. The other type of person, which I kind of fall into, no matter what information I know, unless someone's asking me draw a 100% accurate triangle, a lot of times for this one, I'll still just draw any old triangle and call it A, B, C, and I'll write 110 degrees here. Because my goal is not to draw the most accurate triangle, it's just the triangle I'm drawing is just a tool to help me solve it. Okay, I'm not an engineer. I know this isn't 110 degrees. I'm not going to take my protractor out. But I'm just going to go 110. That way I'm not spending the whole test drawing perfect triangles. But if you like drawing an obtuse angle where there's an obtuse angle, go ahead, by all means, do it. But it is okay just to this and not have to worry about it. So that's 110 degrees. My A is 30 degrees. That means my b, I don't have to do anything else because that's 110 plus 30 is 140. I'm pretty sure I can do 180 minus 140 in my head. I'm pretty sure that's 106 degrees. No, it's 40 degrees. So we already know our angle. The side they give me is 422, and that is A. Let's put that back in black. I don't know B, and I also don't know C. Well, I'm going to ask myself real quick. They gave me this angle, and this side. So that's going to be angle, angle, side. Does that work? Is that one of the ones that I said we could use on the other page? If you're not sure what I'm asking. Yeah, remember I said all you're looking out for is, did I use two angles and a side? Did I give you two angles and a side? So this one's going to work because it is angle, angle, side, or you could say it's side, angle, angle. It's the same thing. All right, either it's angle, side, angle, or it's angle, angle, side. All right, so that's angle, angle, side. So we can do the exact same steps we did in the last one. We're looking for sides. So what I'm going to do is I'm going to circle the one that's already done for me. All my information is down for this one. So I know if I put 422 over sine of 30 degrees, I can figure out my answer. Let's pretend I didn't remember to flip it. Actually, let's flip it first and then let's look at the other version. Okay, so I now know that 422 over the sine of 30 degrees has to equal, what do we want to solve for, B or C? Anyone like B or C? What was that?
Like B.
You would like B? All right, then we'll do B first. So I'm looking for B. Well, according to the law of sines, if I'm looking for side B, I'm going to put that over sine of B. And my sine of B is 40 degrees. Just like we did last time, I'm going to multiply both sides by sine of 40 degrees. So we're going to have sine of 40 degrees times 422 over sine of 30 degrees. That equals B. And that's going to give me B equals about, who solved B? Think we get it? Yeah.
It's about 540.16.
540.156?
Just one.
0.16, so about 0.2. Ooh, I think we rounded a little bit different because I came up with 552.5. There is a chance. Did you do sine of 40, rounded it, and then multiplied it by this?
Yeah.
Yeah. I would just directly type this in. I would type in sine of 40 times 422 over. I wouldn't take any points off on the test. It's just easier on you because your calculator can do all that all rather than trying to round stuff. Yeah.
Okay, because you know A over sine of capital A or whatever, and that just equals straight like 844, could you just multiply that times like at the sine angles and then get everything like that?
Yeah. Yeah. But you're doing the same thing.
Yeah.
This is just a little more accurate because you're rounding a little bit. But yeah, you'll get the same. You'll get close to the same answer. I wouldn't take any points off for that. So what Anisha was saying is, hey, can I just put this in my calculator and then just use that number throughout? And you can. All right? You can just replace this with whatever decimal that comes out to. And then you just got to, like you said, if you recognize what you're doing with the law of sines, it can go real quick. Like you figure out the decimal, and you're just like, hey, I can just multiply it by sine of 40, sine of 110, and I'm done. But I want to do it step by step these first few times. All right, I don't want you to write this down. But I'm going to say, what if I didn't give you that shortcut? What if I just gave you the law of sines? If I just gave you the law of sines and you didn't remember to flip it, you would have something like this to solve. Sine of 30 degrees all over 422. So this is the exact same solving for B. Sine of 40 degrees over B. Where this one I just had to multiply by sine of 40. This one I have to multiply both sides by B. And then I have to divide by this fraction, which, like I said, you don't have to be writing this down. This is the reason why you don't do it this way. So the easier way to solve this one would also be just to flip it. So if you ever find yourself in this realm where you have your variable on the bottom, just flip both of them. All right, take the reciprocal of both of them, and you'll get back to where we started. All right, that's why we did the shortcut, because this is a lot more math than just multiplying by that. Okay, so instead of doing that, let's go ahead and solve for C. Once again, I'm going to stick with that 422 over sine of 30 degrees. But Willie, if you wanted to, you could use your B1 as well. We're going to set that equal to C over the sine of C. Well, the sine of C, C is just 110 degrees. I'm going to kind of skip a step here. I'm just going to say C equals, I'm going to flip the sides right off the bat. So I multiplied both sides by 110 times 422 over sine of 30 degrees. So in my head, I multiplied both sides by sine of 10, and I flipped the sides there around. So what does C equal about? And some besides Brian, because he seems to be the one doing the heavy lifting. Yeah.
793.1.
Say that one more time.
793.1.
793.1. And what exactly? And that's exactly what I got. So I don't think you used the rounded one, did you?
Well, I mean, it's, what I got was, I guess I got lucky too, just like 844 exactly.
Oh, okay.
So I mean, for this one, I guess it was easier.
Yeah. It all depends on how many decimals it's going to have. All right, any questions on any of these steps? So your goal is to figure out which one you know all the information for and use that one to solve the rest of them. But you do need to double check to make sure you were given two angles and a side. Because tomorrow we're going to talk about what happens if you give you two sides and an angle, because it's not the same. It has the same steps in it if it's correct, because something happens when it's side-side angle. If you remember from geometry, that was the one that you couldn't use to do anything for. It was that side-side angle, and I always remember because if you spell it the wrong way, it's not a good word to say in math class. All right, it's a weird one, and if you don't remember why it's weird, we're going to go over it tomorrow because it leads to a whole bunch of opportunity. All right, before we get to that, let's go ahead and look at solving triangle ABC, where A, or alpha equals 28, beta equals 66, and C equals 8.2. So even though we have alphas, betas, and probably gammas and stuff, what I typically do is I still just draw my normal triangle. And because repetition breeds success, I'm just going to still label them A, B, and C. I'm not going to use alphas or anything. I'm just going to know in my head, hey, instead of alpha, they're just asking for the angle of A. Alpha goes with A. So I'm just going to write A is 28 degrees. Beta, well, that's going to go with B. I mean, it makes sense. Beta, B. So that one's 66 degrees. And I'm not going to solve that one yet. All I'm going to do is I'm going to write down, hey, C. So C is opposite of angle C is going to be 8.2. So I need to find side B. And I need to find side A. I'm going to put a little note down for this one, okay? You're going to need it for the test. A lot of times we say alpha is A's, beta is B's. Does anyone know the Greek alphabet that what C would be? Want to take a guess? It's gamma. Yeah. Gamma's the weird one because it looks weird and it doesn't quite look like a C. So when you're doing the angle of C, I'm going to put a little note down here. It looks like a little Y. That is gamma. And it is going to be on the homework. They're going to give you gamma. So I'm going to know what. You can't, if I give you an angle, you have to know where it goes in the triangle. You don't get the pick. So if I give you a triangle on a test and you think you're picking which angle it goes to, that'd be a good time to say, Mr. Pavian, which angle are you asking? And I'll tell you what angle I'm talking about if I use the Greek letters. Okay? But that is gamma. I want you to finish this one. And when you are done, just raise your hand and I will say yes or no. And if you're good, you can move on to the homework. If not, you can never move on to the